Right. Okay. Assalamualaikum and good morning. Yeah. How are you? I hope everyone's fine. Yeah. Let's continue with ionization energy. Okay. Now, um, ionization energy, as the name implies, it has something to do with atom becoming ion. Yeah. So atoms are converted to ions, cations. The process is called ionization energy. Now, the definition of ionization energy is the minimum energy required to remove an electron from a gaseous atom or ion. Yeah. Now, if you refer to this model, yeah, at the center we have nucleus, nucleus, and surrounding the nucleus there are electrons. Between the nucleus, between the nucleus and the electrons, of course, there are attractions. Attractions. This electron is attracted to the nucleus. These electrons are attracted to the nucleus, as well as the electrons in the valence shell are attracted to the nucleus. Now, we have seen that as the electrons are farther away from the nucleus, the attraction is weaker, right? And if we remove electrons, the removal will start from the valence electrons. We always start from the easiest. Yeah, we start here. We start removed from the valence shell. Now, every time electron is removed, okay, for example, let's have a look at the first ionization energy. First ionization energy refers to the first electron being removed from the atom. Yeah, first electron. Say that in this case, this is the first one. Yeah, this electron is the first one here. Now, say that this element is element Z. Yeah, Z is neutral atom. Yeah, neutral gaseous atom at the very beginning. And when one electron is removed, yeah, what happens to Z? Z will be Z plus. So ionization energy is the process of forming cation, not anion. Anion has a different one, a different process. So for this ionization energy, we have it is the minimum energy required to remove an electron from an atom. Yeah. For the first definition, the reactant is an atom. But let's have a look at the second ionization energy. Second refers to second electron. See, we have removed the first electron here. Now we want to remove the second one. Will the process be more difficult or easier? Of course, more difficult. Yeah, because, okay, you imagine you don't have enough money and maybe you have allowance of 10 ringgit every day. Your mother would like to cut it to 9 ringgit. How would you feel? Not enough, right? So not enough. That means the attraction of the valence electrons to the nucleus is much stronger. But uh, the process must happen. The electron must be removed. Uh, Therefore, the process will be or will require more energy because it is more difficult. Therefore, second ionization energy is always higher than the first ionization energy. The third one will be more difficult than the second one. And the fourth one will be more difficult than the third one. Right? So the process here will result in Z2 plus. Okay, look at the reactant here. The reactant is an ion. Therefore, For second ionization energy, the definition will be the minimum energy required to remove an electron from an ion, not atom. Atom is only for the first ionization energy, right? Okay, are we okay? Okay, let's proceed. Okay, now, trends of IE, yeah, we have across a period and down a group. What affects IE? Yeah, what affects ionization energy? As we can see before, the closer is the electron to the nucleus, which means the stronger is the attraction of the nucleus towards the electron, then it will be more difficult to be removed. Okay, let me write it so that it will be clearer to you. Okay, the stronger is the nucleus attraction, okay, will be more difficult or easier to remove electron? More difficult, right? Okay, more difficult to remove electron. Therefore, the energy needed will be higher. Yeah, hence IE is higher. Now, across a period, what happened to nucleus attraction? Nucleus attraction gets stronger, right? Okay, nucleus attraction is stronger. Therefore, what happened to IE? Stronger attraction means more difficult. Therefore, IE increases. What happened down a group? Okay, what is the factor for down a group? The factor is shielding effect. Down a group, the shielding effect increases. What happened to the nucleus attraction? Nucleus attraction towards the valence electrons become weaker. Therefore, IE also decreases. Right? Okay, now let's have a look at the calculation question. Okay, I'll show you one example. How do we use these values of ionization energy? One of it is to determine the number of valence electrons. And there are two methods, ratio method and difference method. But we focus on ratio method. Now, okay, I'm using question 8, element J as example. So what do? We calculate all the ratios. IE2 over IE1. IE3 over IE2, IE4 over IE3, and finally IE5 over IE4. Now, the values are 2430 over 801, plus the unit. And if you calculate, you will get around 3.03. IE3, 3660 over 2430, and you will get a value around 1.50. And for IE4 over IE3, the values are 25,000 over 3660, and you will get 6.83. And finally, you have 32820 over 25,000, and the value will be 1.313. Now, look for the highest ratio. Yeah, in this case, it is 6.83. Okay, what does this mean? IE4, yeah, when the ratio is high, that means the number above is very, very high compared with the number before. In this case, that means to remove the fourth electron is very, very difficult, yeah, compared with to remove the third electron. That means the fourth electron must be much closer to the nucleus, and that means it is removed from inner shell. If there are if the fourth electron is in the inner shell, how many valence electrons does it have? Okay, before 4, there are 3. That means the number of valence electron is 3.